So let's just jump right in. How old is a star? It seems like a pretty simple question, doesn't it? Kind of like asking how old a tree is. You just count the rings. But when you look up at the night sky, you're actually staring at one of the biggest, most fundamental mysteries in all of astrophysics.
See, here's the thing. Stars don't exactly come with birth certificates. We can't just hit rewind on the universe and see when one first lit up. So to get to the answer, astronomers have to become these cosmic detectives, piecing together really subtle clues from light that might have traveled for millions or even billions of years just to get to us.
And this really gets to the heart of the problem. It's a direct quote from the scientific paper that inspired this whole explainer. It says, "The age of an individual star cannot be measured, only estimated." And that one word, estimated, well, it's everything. It tells you right away we're in the world of forensics, not simple math.
Okay, so let's officially open the case file on this cosmic age mystery. We're dealing with a truly fundamental puzzle here. A case with literally no witnesses to the main event. And solving it? Well, it's the key to understanding just about everything, from the future of our own sun to the entire history of the galaxy.
This right here, this lays out the detective's dilemma perfectly. First off, every single method we have is indirect. Some of them rely on these super complex theoretical models of how a star should behave. Others are more empirical, based on what we can actually see. But here's the real kicker. There's no magic bullet. No single technique works for every kind of star or for every stage of a star's life. So with all those challenges, where does a cosmic detective even begin? Well, it turns out if a single star is just too tough a case to crack on its own, you look for its family. You turn to star clusters. And these clusters have become our Rosetta Stone for figuring out stellar ages.
So what exactly is an open cluster? Just think of it like a stellar nursery. It's a place where hundreds, maybe thousands of stars were all born at pretty much the same time from the same gigantic cloud of gas and dust. They are, for all practical purposes, cosmic siblings who all share the same birthday.
And that shared birthday, that's what makes them so unbelievably important. Because all the stars are the same age, these clusters give astronomers a perfect natural laboratory. It's like a control group. They can watch how stars of different sizes and different masses all evolve together, side by side. This is how they test their theories and fine-tune their tools, which they can then go and use on those trickier cases of lonely, isolated stars.
All right, so using these clusters as our baseline, let's open up the detective's toolkit. Now, as you'd probably guess, not all clues are created equal, and astronomers have a pretty clear hierarchy of the methods they trust the most.
So at the very top, you've got your most reliable techniques, like using those star clusters we were just talking about. That's the gold standard. In the middle tier, you've got some pretty good indicators, like how fast a star is spinning. Fun fact, younger stars tend to spin way faster than older ones. And then down at the bottom, you have the less certain clues, like how a star is moving through the galaxy. So what this all means is, an astronomer has to pick the right tool for the job and know exactly how much to trust the answer it spits out.
But ultimately, all of these tools fall into two main camps. On one side, you've got the model-dependent approach. This is kind of like having a detailed textbook on how a star should age, and you're just comparing your star to the pictures in the book. Then on the other side, you've got the empirical approach. This is just pure observation. You notice that stars with a certain property, like a fast spin, almost always have a certain age. You need both of these to build a strong case.
Okay, so with all these incredible tools, all this data from clusters, and decades of really clever detective work, how good are we actually at telling a star's age today? Well, the scientific paper we're pulling from is refreshingly honest, and it delivers a pretty blunt verdict on the current state of the case. The paper states that our current ability to figure out the ages of even the stars closest to us, our own cosmic neighbors, is, what do you think? Excellent? Good? Maybe?
Mediocre. That's the word they used, mediocre. Not terrible, but let's be honest, it's not great either. It's actually this amazing moment of scientific humility, because it shows you just how massive this challenge really is. Even with all our incredible technology, we are still just scratching the surface of this cosmic mystery. But hang on, don't get discouraged, because just as the paper delivers this mediocre verdict, it pivots right to the future. It highlights that a major breakthrough in the case is basically already happening.
The authors say that the next few years hold great promise, and that promise comes from a revolutionary new field that's going to let astronomers do something they've never, ever been able to do before: actually see inside a star.
And that field is called asteroseismology. Just think of it like seismology here on Earth, where we study earthquakes to figure out what our planet's core is like. Well, astronomers can now study starquakes, these tiny, unbelievably subtle vibrations on a star's surface to understand what's happening deep down in its core.
And this is the game changer. For so long, we've been stuck just looking at a star's surface, which is kind of like trying to guess a person's age just by looking at their skin. Astroseismology lets us peer inside, right at a star's heart. This gives us incredibly precise data that is going to push our models and make them radically better. The bottom line is this: we are finally starting to move from just estimation towards certainty.
Which really just leaves us with this one last massive question. We know that stars are basically the universe's timekeepers. They're the factories that built the elements we're all made of. They record the history of our galaxy in their light. So what new, incredible, untold chapters of cosmic history will we finally be able to read when these stars can at last tell us their true age?